All right, hey scholars. I am not at school today because of my awesome daughter Stephanie is competing for the 800 meters at the state track meet for Wheaton Academy, and we're hoping she represents the school well. So just pray she runs fast. But also besides that, you should have already watched some questions being answered. I apologize for the last one on number 11 about understanding how to factor better. We're going to use factoring today to help us out, but we are going to talk about today, and I want you to write up on here, we go, Algebra Review, Day 4, we're say rational expressions, which means we're working with fractions, but not just any old fractions, fractions with factoring and stuff involved. So a few things you always need to remember. And I'm going to take it easy and I'm going to make it hard. Easy then hard, hopefully all together, is when you work with fractions, all right, and rational expressions, you should always reduce or simplify, right, your fractions. There should be no thought otherwise. So for instance, if you had a problem like 15 over 75, so an answer like 15 over 75, you wouldn't leave it in that form. Instead, you'd sit there and say, you know what? I can simplify out 15 from both of those, and you'd reduce it down to 1/5, and you get the simplest form. And remember, if you don't have things in simplest fraction form, it doesn't work. So then we crank it up a notch in algebra world. So then we get something like this, 81x cubed over 18x. So one thing that we need to remember is that you need to think about, all right, what numbers or what ways can I simplify this the most? Well, let me remind you a little bit about exponents and stuff, but let's make sure, I'm going to rewrite this so I can mark it up, but you can still see the original problem. First thing I always look at is okay, is there anything that can come out of both 81 and 18? And the answer is 9 can come out of both. I can simplify them both by 9. So this would be 9 and that would be 2. So we divided 9 out of both of them. Beautiful. But then we have an x cubed and an x to the first. So one thing you need to remember is when you are reducing exponents, that you always look at the larger exponent and subtract the smaller one when it's in a fraction, and then you leave it where the larger one is. So here I have a 3, here I have a 1. So when I'm simplifying it, I actually get an x squared in the numerator and then just a 9 in the a 2 in the denominator. Because 3 minus 1 is 2. But let me really explain what happened. Remember, I have 3 x's in the numerator if I have an x cubed, and I have 1 in the denominator. But if I'm simplifying it out, those would be 1, and what's left? An x squared in the denominator. So it's just a shortcut idea when you're dividing with exponents, you just use subtraction instead of multiplication. So something that you're supposed to know. But of course, we don't keep it quite that simple. Then we decide to give you something like this, x minus 2 over x squared minus 4. Now when you look at it, you're like, I can't simplify anything. Or a lot of people go, oh look, I can take an x out of an x squared. Well, my friends, that is not true. So please don't do that. But instead, you need to make sure that you do the following. Factor the numerator and factor the denominators as completely as you can. Well, the numerator, I can't factor anything, so I get an x minus 2. But the denominator, right here, it's not going to let me highlight here, sorry. The x squared minus 4 is actually a difference of 2 squares. So I get here an x plus 2, and I get an x minus 2. So what happens? Well, I simplify out with a 1. So I get 1 over x plus 2. That is the fraction reduced in simplest form. But of course, do you think it even stays as easy as that? And the answer is, oh no. You're going to have an x squared minus x minus 12 over an x squared plus 5x plus 6. Now the key with doing all of this stuff that we're doing today is that we're going to get common denominators. We're also going to always factor as much as we can. So in this case, I have to factor the numerator and the denominator both. So let's just look at the numerator first. We'll do the numerator in green. So I look at this and I look to see if there's a greatest common factor. There is no greatest common factor, so I know I'm going to put my two sets of parentheses. So with that, then I look at my end sign and I know it's a subtraction. So I have a plus or a minus. And then I have my x squared, so I know I'm going to have an x and an x. And then I think what two numbers multiply together to be 12, but their difference is going to give me 1 because I have different signs. Well, that's going to be 3 and 4. How do I check? Make sure you OI. I get a negative 4x plus a positive 3x. It gives me a negative x. So we have factored the numerator. Now let's factor the denominator. Okay, we're going to do that in blue. I look for greatest common factor. There is not one. So instead, I'm going to go ahead and get to my two sets of parentheses. I go look at my sign. Oh, that's positive. Then I look to see what they both are. They're both addition signs. So plus, plus. Remember, if this was just happened to be negative, like this one right here just happened to be negative, remember it's both subtraction signs there, but they're both addition signs this time. I have an x squared, so I have an x and an x. And then I have a 6. Well, then I have to go, what two numbers multiply together to be 6, but possibly add together to be, that will add together to be 5, and we go 2 and 3. Now, do you see anything that's the same in the numerator and the denominator? Yeah, they're both the x plus 3's. I simplify them out for 1. So what's left then? Then you get x minus 4 over x plus 2. Do not simplify the x's or the 4 and the 2. There's an addition subtraction sign in there. You cannot do that. If there was a multiplication sign there, that would be something totally different. Now, that doesn't seem too bad, does it? Well, we keep doing stuff with that because besides just simplifying those, we're going to multiply and divide, all right? So what happens when we multiply, divide, and simplify still when we have rational expressions? Well, not too bad. I'm going to give you two easy examples, and then we're going to be two hard examples, okay? So there's well, actually, I'd say one easy example and then two harder examples, but it's not that bad, all right? So think about this for a moment. What if I'm multiplying two fractions? Like negative 2/5 and 20 over 13. What if I was simplifying those? Well, one thing that I could do is that I could multiply together, numerators together, denominators together. So I end up getting a negative 40 over 65. Then you look to see if there's anything you can simplify more. And remember, 5 can come out of both. So this would be 13, and that would be a negative 8. So my reduced fraction's a negative 8 over 13. Not too bad. But however, you were also taught that sometimes it's easier to simplify before you multiply. So rewrite negative 2/5 and 20 over 13. Now I'm going to simplify. I'm going to say, all right, can 5 or 2, can I go denominator numerator simplification here? I can take a 5 out of the denominator here and get 1, and I can take a 5 out of the 20 and make that 4. There's nothing else I can reduce when I'm multiplying. Remember, this has to be with multiplying, not adding or subtraction. So I multiply then my numerators together, and I get a negative 8, and my denominators together, and I get negative 13. Now, a lot of you, I think, are good both ways, so just make sure you pick a method that works. But remember, I'm just going to do the same thing when I'm working with fractions. So I get here, I get 4x over x squared minus 4 times x plus 2 over 16x. Now, the key with these is like we did earlier on the last page or the previous problems. We always factor these rational expressions first, these fractions. So the top of the numerator of the first one I can't factor, but the bottom one here, I'm going to highlight that in yellow, I can factor, which is going to end up going, it's a difference of 2 squares, so I end up getting an x plus 2 and I get an x minus 2. Then I go, all right, I need to factor my other one. Well, an x plus 2 cannot factor out, so x plus 2 stays the same in this problem. So I'm looking at this one now, and I get a 16x. Nothing really factors. But now I can reduce because I'm multiplying these together, kind of like what we did on the top right one. Because look here, guys. Do I have an x plus 2 in the numerator and an x plus 2 in the denominator? Yeah, they simplify out to 1. Look here, I have an x and an x. What do they simplify out to be? 1. I have a 4 and a 16. 4 can go in itself once. 16 how many times? 4 times. So my numerator all became 1 times 1 times 1, which is 1. All over, what's my denominator here? I got 1 times x minus 2 times 4. Well, because we just want to keep this easy on ourselves, we don't distribute the 4 through. We just leave it as 1 over 4 times x minus 2. It is fine if you get 1 over 4x minus 8. You just don't need to take the time to do it. It's not that bad, is it, guys? Well, let's try another one. What if I did this? 2 minus x over x squared minus 4. Now, when I look at this, I don't do anything with the 2 minus x. It doesn't have a greatest common factor. But the denominator I do see is a difference of 2 squares again, just like our previous problem. Unfortunately, it looks like we can't do anything with this problem because I have a 2 minus x on top, but I have an x minus 2 on the bottom. But here's where you can use factors to help you out. Guys, can I factor out a negative 1 out of 2 minus x? If I do, I end up getting a positive x, but a negative what? 2. So notice these two now can simplify out. And so you end up getting negative 1 over x plus 2. Isn't that cool? Now someone goes, whoa, 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 where did you get the negative 1? Remember, I took this one and I took a greatest common factor out of a negative 1. So I divided out, I undistributed it. So that's where I got the negative 1 here. Which when you do that, that changes the signs of things. So the x became positive and the 2 became what? Negative. And then you reduce. So do your heads hurt yet? Yes, well, we're not done, my friends. So we're not done. We're just warming up. We still haven't done any division problems. So what if I divide? Well, let's see what happens here. All right, so what if we're dividing? What if I had 2/3 divided by 5/9? How would you guys solve that one? Well, you would hopefully remember the rule that if you divide by a fraction, it's the same thing as multiplying by its reciprocal. And then when you do that, you just simplify and you'd end up getting 6/5. Now remember, I can cross reduce like that because it's multiplying. If there was an addition sign there, I cannot do that. No, 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 not at all. It has to be multiplication sign. All right, so we get 6/5. What happens if I make it a little bit more complicated? Like maybe like this one, x squared plus 7x plus 12 over x squared plus 3x plus 2. Divided by, oh yes, we have more, x squared plus 6x plus 9, that's a lot, over x squared plus 5x plus 6. Oh, sorry, it just rotated on me. All right, so to do that, you need to do like what we've done before. We need to factor. And we also remember that when we divide, we're going to be multiplying by its reciprocal. So let's do the first problem. All right, to factor in the numerator, I look for greatest common factor. There's not one. I look at the sign and I realize they're both addition. You should have your x and your x. What two numbers multiply together to be 12, but add together to be 7? And that's going to be 4 and 3. In your denominator, do not have a greatest common factor again. So then I look at my signs and they both end up being addition again. I have my x and my x. And then what two numbers multiply together to be 2? We got 2 and 1. Again, check yourself by oing, making sure that you get these right. Now, here's where I need everyone to do. I'm trying to save us some steps. So remember, this is going to flip over if I use a multiplication symbol. So really, I'm looking at this first, and I'm going to put it in the numerator because I'm multiplying by its reciprocal. So when I do that, so I'm going to change colors here. I still want to look for greatest common factor, and right here, guys, remember, because I flipped it over, and there isn't one. So I look at my signs, I get a plus plus, so I get plus plus. Then I have an x squared, well, that's x and x, and then what two numbers multiply together to be 6, but add together to be 5? That's right, 3 and 2. Then we're going to do the denominator, remember, goes into the numerator goes into the denominator, right? So when we're doing this, I do the same thing. I look for greatest common factor. There isn't one. I look for my sign, so I get addition, plus, plus. What do I do? Well, I put my x, and then it ends up being a perfect square trinomial, so I know that this would be 3 and 3. Now I can take the time. Oops, I didn't write my 3 out very well, did it? All right, so 3 and 3. All right, now we can use this to simplify things as much as we possibly can. Like for instance, and I'm going to use a gray one here to show simplifying. Do you guys agree with me? Those both simplify out to 1. But I also have an x plus 3 over here and an x plus 3 here. So they're gone. Do I have anything else I can simplify? Well, I notice that there's an x plus 2 in the numerator here and an x plus 2 in the denominator there. So remember, these are simplifying out to be 1s. So if you do that, I then go like, I don't think I can simplify anymore. So now I multiply denominators together and numerators together of the two fractions and the denominators to 2 of the fractions. So what do we get? X plus 4 over x plus 1. All right, so we're getting it a little bit better here, right? So, not quite done yet, my friends. We still have a little bit more to go. So I'm going to pause this while I go and get my charger. All right, hello, scholars. We're going to keep going on this. All right, so we now have done just simplifying fractions, basically. So simple stuff before, just simplifying it. Just a fraction with rational expressions. We've multiplied or divided. Again, we had to simplify. We talked about those. But now what's the two operations we haven't talked about yet with fractions with rational expressions? Adding and subtracting. So when you work with this now, we got to make sure we're doing number 3, the process correctly. We have to make sure that we add. All right, doesn't want to write for me here real quick. Trying to get that done. We need to add and subtract rational expressions. We need to add and subtract, and then we need to simplify. All right, so let me help you out with this one. So let me give you an example of a simple problem that we've had in our past, okay? For instance, if you had a problem like this, a negative 4/9 plus 3/7. What would you do in order to add those fractions? You would get a common what? Denominator, right? So you'd get the fact that the common denominator between the two would be 63. How would you get them both to have that common denominator? Well, you would sit there and say, okay, what do I multiply the 9 by to get the 63? Well, you'd multiply by a 7, right? But you'd have to do it both to the numerator and denominator, right? So that would get a negative 28/63. I'm going to rewrite that because I think it looks better a little bit like this. Correct? Now, I want to get 3/7 to have a common denominator of 63. Well, that meant you had to multiply both the numerator and the denominator by 9. So when we got that, we got 27/63. Well, a negative 28 plus a positive 27 is a negative 1/63. Now, same stuff still happens when you make it a little more complicated. Okay? So with this one, what if I had a problem like this? 2x minus 1 over x plus 4 minus 1. It looks like you can't do anything, but you need to remember that 1 turns into 1 over 1. Then I look at my denominators, and you always factor first if you can, but since I can't factor, I look, all right, what's my common denominator between these two? Well, the common denominator is really 1 times x plus 4. That's going to be an x plus 4 for both of them. Well, the cool thing is that means I don't have to do anything with my first fraction because that's just really multiplying both the numerator and denominator by 1. But on this other one, that means I have to multiply by x plus 4 times x plus 4. We're going to have a subtraction sign here. So we got negative 1 basically times x plus 4. Well, let's make sure that we simplify stuff correctly. Now they're the same denominator, we can combine them, right, guys? So I got x plus 4. I get here on the left a 2x minus 1. I distribute my negative 1 because of my negative sign here. Don't forget that. So I get a negative x minus 4. I have to simplify completely my numerator. So 2x minus x is x. A negative 1 minus 4 is a negative 5. The x over 4. So x minus 5 over x plus 4. Now, seems complicated, but remember, what are we doing? It's the exact same process that we did up here with numbers. It's just that we're going to have algebraic expressions that we're working with instead. All right, now let me try another one. Maybe a little more complicated, but I think you guys can get it. All right, what if I had this problem here? 1 over x squared plus 3x plus 2 minus 1 over x squared minus 2x plus, minus 3. Make sure I got the right numbers here. Minus 3. All right. Now, in order to do this, I have to have a common denominator, correct? Which means you need to factor both of your denominators before. So I'm going to do this quickly. So with this, I'm going to factor x squared plus 3x plus 2. So I know what I have. Well, that factors into plus plus x, and I get a 2 and a 1. I check that carefully, and it works. Now, I do the same thing over here. I have to make sure, and the reason why I have to have them factored is so I can quickly find a common denominator. And my x squared minus 2x minus 3 tells me I have a plus and a minus sign because a negative 3 tells me different signs. I have an x and an x. And the two numbers I have together to multiply to 3 are just going to be 1 and 3. And then I do my OI, negative 3x plus a positive 1x. That gives me a negative 2x. I know it's correct. So really my fractions now are 1 over x plus 2 times quantity x plus 1 minus 1 over x plus 1 minus x minus 3. Now guys, what's going to be my common denominator? Well, my common denominator has to have an x plus 1 in it. We have that in both. But it also has to have an x plus 2. And it has to have an x minus 3. So I get here, and we're going to put on this side, we're going to have an x plus 3. Actually, let's do it like, I think we're going to rewrite it this way first. Let's rewrite this now with the factored denominators. I think this will make a little more sense. Minus, let's go 1 over x plus 1 times x minus 3. Now remember, I want a common denominator. So I look here and I look for the least common denominator. I know in this answer I have to have an x plus 2. So I'm going to have an x plus 2. I need an x plus 1. Well, the good thing is I have that in both. So I have an x plus 1 is going to be my common denominator. And we're going to have an x minus 3. So I have all of those as factors for the denominator of my fraction. So now I have to ask how I'm going to change the first fraction in order to have the quantity x plus 2 times quantity x plus 1 times quantity x minus 3 in the denominator. Well, you're going to multiply whatever you need to make that denominator. So I'm going to multiply by an x plus 3. But that means I also have to do it to the numerator. So I get 1 times x plus 3. That gives me an x plus 3. Now, what do I have to multiply in the denominator? Well, that's going to be an x plus 2. So I'm an x plus 2. Now remember that's a negative 1, so you can move the negative there if you want to, and that gives me a negative x minus 2. So what are we going to do? Well, we're going to simplify it together. Well, x plus 3 minus x minus 2, well, that gives me what value here? Oops, I think that's supposed to be an x minus 3. Oops, I had a plus 3, guys. This was an x minus 3. I'm making too many mistakes on this video, so please forgive me on that. Give our x minus 3. I'm going on a little sleep, so forgive me for doing this. But combined like terms, I get a negative 5 over x plus 2 times x plus 1 times x minus 3. Notice for all of these problems, I'm not taking the time to multiply them together. Partly because you just don't need to, because it's already in reduced form, and it's not going to accomplish what we need to by multiplying it together. We're already in the reduced fraction. Now it's time for me to, guys, try one of the hardest problems for you, okay? It's going to be combining everything that we've done. but I think you can do it. Now, I've seen simpler problems like this on like ACT, SAT type questions, but here's what we're going to do. I need you to do the following. We're going to simplify the following problem. X minus y over the quantity x plus over y plus y over x. All right, so what do you have to do first? Well, first thing you have to do is I need to, in the denominator right here, I need to combine it. I need to get a common denominator and solve. So I'm going to leave the x over here alone. I'm going to leave the y alone. But now I got to get a common denominator for my fractions in the denominator. Well, that's going to be xy. Well, what am I going to do here? Well, on this one, that means I'm going to multiply by x and x. So I get an x squared. Over here, that means I multiply by a y and y. So I get plus y squared. Now, we're going to rewrite it, because remember, if I divide by a fraction, it's multiplying by the reciprocal, so I get minus y over 1 times the quantity xy over x squared plus y squared. All right, so what do we get here? So we get x minus, because I multiply numerators and denominators together, xy squared over x squared plus y squared. All right, so how do you think we're doing so far? Have I lost everyone? Probably. But remember, really, what did I do? I made sure I combined my fractions in the denominator of the fraction on the right by getting a common denominator. Then, because I'm dividing by a fraction, I multiplied by the reciprocal of it, so xy over x squared plus y. Then we just multiplied our two fractions together, so y times xy over x squared plus y. Now we're to the point where we have to get a common denominator. Because remember, this would be over 1. Well, what's that common denominator going to be? Well, that's going to be an x squared plus y squared, because at 1 times x squared plus y squared, that's what we get. So what do I have to multiply this fraction by? Well, I'm going to have to multiply by x squared plus y squared. Over here, I'm going to x squared plus y squared, right? Now, I make sure I distribute this carefully. So I get an x cubed plus y squared minus x y squared over, and remember, we have our fraction here, x squared plus y squared. Now, let's look. Oops, did I get x squared? I forgot my x right here when we distribute. Sorry. Everyone see that? Now, when I look at this, I'm now going to combine like terms. So now I get x cubed plus xy squared minus xy squared. Don't these two here, make sure I write that so it's a little bit more readable. Positive xy squared and negative xy squared simplify out to be 0. So then I get x cubed over x squared plus y squared. And that, my friends, is simplest form for that rational expression. Now, I have given you guys a lot of problems, and they're hard. No, on Monday, I probably spend 20 to 25 minutes probably just answering this, and then we'll do some review for the final. But I just want to make sure you understand how to do this, so that way you can do well on the problems that I picked that are going to be on the quiz next Tuesday. I also should be available Monday during lunch or before school if you have questions as well. You can also call me on Sunday if you have questions. So hopefully, guys, I haven't confused you too much. Don't worry, take the time. I know I made some little flubs here, and hopefully I got them fixed for you, but go back and rewatch the problems as well.